from Japan. I was born in Japan. Ooh, from Puerto Rico. Awesome. All right. So what I need from you guys today, the first thing you're going to do is if you do not have an Amplify account for amplify.com, you need an Amplify account. Okay. And Mr. Brandon, if you want to join this class too, you can. I think I can add you as a teacher in there. But what I'm going to do is I'm going to give you the link to our Amplify classroom for our 10:30 class. Right. So what I need you to do is click on this link that I just put in chat. If you do not have an Amplify account, you will be asked to create one. Use your school email and create it through Amplify. If you log in with Google, and here's the code it's going to ask you for if you have to create an account. If you log in with Google, you're going to be asked to remember that. That's the problem. And a lot of people forget that they logged in with Google and it causes some issues. So if you already have an Amplify account, click Login with Amplify. And if you do not, click Sign Up. And you are a student, unless you're Mr. Brandon. Okay. And then you would enter that code that I just put in the chat and click Join. Okay. Once you click Join, then it's going to ask you for your first name, last name, and you can use your TIVA school email here, or just create a username. As long as you know your username, it's fine. But I would advise using your school email. Okay. This way you can have a record of these. This is how I do notes in class. This is my primary method of doing notes in class, is using Amplify. The reason I do that is normally when I have more time beforehand, to put it in Amplify, I will have the answers coded in for you, and you can access it later as well. So please join our Amplify classroom. It is very important that you are in the Amplify. If you, however, are one of those people, and here's the assignment directly if you can't get in yet. If you are one of those people who would prefer to have your own copy of the PDF, here you go, putting it in chat. If you are one of the people who has access to Kami, hold on, give me a link. You don't know your user email? Use your school email to create an account. Okay. If you have trouble creating an account, use one of the PDF versions for today and send me an email. So if you don't know your school email, you can just create a username, and I can always access that too. I can only access it once you do have an account. So try using your school email to create an account if you know one. Create a new account if you have to. Because if you do that, it will give me your usernames and passwords. Well, not passwords, but it'll give me like something that you can use to log in. Okay. While you guys are doing that, I'm going to go ahead and go over our reminders for the week, because I know if I don't, I won't get to it. Haha. So your asynchronous assignments. These are the modules they want you to work through. The simplify radical expressions, operations with radical expressions, perfect square equations, and completing the square, and then the quadratic formula. Every quarter, this means from now till spring break, and then from spring break to the end of the year, you have to get 360 minutes in IXL. We will be doing 20 minutes a week in class as much as we can, but you should definitely work on it outside of class as well. I will be setting up a prize account or a prize for the top 5 people who put in the number of minutes, but I'm working on how I'm going to work that out yet. The IXL skills that are equivalent to these modules are listed here. If you search out these skills, then you can still get minutes, while continuing to get practice in the skills that you need to pass this class. And more importantly, sorry, I know it's probably not important, more importantly to some people, but more importantly, pass the STAR. It's Texas. You want to get that STAR test out of the way. So as a reminder, quick question, guys. You are legally required to take the STAR, right? Everyone knows that. There are only 3. No worries. Don't worry. Okay. Since you are legally required to take the STAR, how many times do you want to do it? On that link, I'm not sure how to fix that. So you can if you go up a little bit above that, you can just click download and save it to your computer and use it. Or you can go to the Amplify version. You only need one. These are all the same document. Every single one of these is the exact same file, right? And Riley, you have it right. If I have to do it once, I only want to do it once. All right, so let's just keep that in mind. All right, so if you are using the Amplify, you will notice that the second slide has the key to success, which is something that my class came up with last term. Perfect. Okay. You'll notice slide 2 is a link to the Desmos testing calculator. Always, 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 always open Desmos. Desmos is our bestie. It is our key to success. It will pretty much do the test for us as long as we know what to tell it to do. Okay? Now, I need everyone to make sure you're paying very close attention to what I'm about to say. Desmos is a computer. Computers are only as smart as the people using them. But that's the thing. They don't have to be they just have to know the instructions. You have to tell it what to do. So if you can tell it what to do, it will do it for you. Okay, it's so important that you know how to tell it what to do. All right. So when we're using Desmos, make sure you're paying attention, because while we do Desmos, it's a lot faster than doing it by hand. And if you know how to put it into Desmos and you understand why we're doing what we're doing in Desmos, it can do all the hard work for you. Okay, you do the easy part, it does the hard part. All right. Thumbs up if you understand that Desmos is only as good as its instructions. Okay. Computers are only as good as their instructions. This is also why we don't want to use AI to teach us our math, because sometimes the AI is wrong. Because the AI is looking over the entire internet for answers. Okay. And unfortunately, it can find wrong answers too. Hold on, guys, don't answer the question yet. It's going to deactivate. I don't know why, but there's no setting in Engagely to turn off if you move the screen, we deactivate the poll. You have to do that manually. It's silly. Okay. All right, so guys, go ahead and answer this question. Just put it on the screen. First answer, second answer with commas, or I think you can actually submit multiple responses. So square root of 25, square root of 64, and that should be square root of 81. I'm sorry, there's a mistake there. Dang it. Okay, so I'm not going to do this poll. All right, guys, what's the square root of 25? Perfect, Alexandra. What's the square root of 25? 5, perfect. And the square root of 64? Yes, you get Desmos on STAR. 8. And the square root of 81? 9. Perfect. Yes, you get the Desmos testing calculator, the one I linked in chat. And if you need it again, here it is. This is why Desmos is our bestie. This is the calculator you get to use on STAR. It is embedded into STAR. Okay. So what we're going to do today is we're going to learn how to factor a part of an expression called the radicand so that we can simplify radical expressions and identify perfect squares and create simplified radical expressions. All right, so in the chat, y'all have a sort on the amplify, so you're going to sort them. But in the chat, somebody tell me one of the perfect squares you see here. Does anyone see a perfect square? $25, perfect. Oops, I am not in my correct location. Here it is. Okay, we got 25. I see 4. I see 100. And I see 49. Any others? Is that all of them? I think so. 7 squared, 2 squared, 5 squared, 10 squared. How do you find them? It's mostly, do you know which ones are perfect squares? 27 is actually a perfect cube. It's pretty cool. Knowing your perfect squares is good. But what if you don't know if a question, that's a good one. What if you don't know? Okay. All right, well, let's look at this Desmos thing. I'm going to show you on a table. Okay. All right, so I'm going to say x and square root of x. All right, see how some of these numbers on the second column here are whole numbers? 1, 2, 3. Thumbs up if you see that. Okay. Any number in this first column that has a perfect whole number in the second column is a perfect square. Any number that has a decimal in the square root column is not a perfect square. Okay? So if you're not sure, let's say I'm given the square root of, give me a number, just any number, first number in chat. 79. Since it's not a whole number, it's not a perfect square. The closest perfect square to 79 is 81. All right? So perfect square, not a perfect square. Everyone good? Thumbs up if you're good with figuring out if it's a perfect square or not. Okay. All right. So for the person who thumbs down, that's okay. Anytime in Desmos, if you go type, what you're going to do is use Desmos. You can either type SQRT or go into the math keyboard in the lower left-hand corner and click the square root button, the radical button, and then you just type whatever number you're looking at. So it'd say square root of 41. 41 is not a perfect square because the answer is a decimal. But 49 is because the answer is not a decimal. Okay. Right. Now, notice how the exponent on all the perfect squares is 2. There's something I need to show you. We have parts of a radical, okay? So we have what is called an index. Most of the time, see how there's a little number here in the V section of what is called the radical? This squiggle mark, this square root mark, this is called a radical. It's totally cool, absolutely groovy, and bodacious. Are those all synonyms for radical, I think? Those will work. All right, so this is called a radical. All right. In this little V section, right here on the outside. This is called the index. But at this time, we will rarely have an index, okay? So if there's no index, the index is, now let's see if you can guess. If you look here, if I say anything with a cube root, okay? So notice how on the outside, this little v here matches my exponent here. So if there's no number inside the little v, what number do you think goes inside the little v? If there's no number in the v, what number do you think goes in the v? 2. Perfect. This is one of our invisible maths. Okay, there's a lot of invisible math in the world. Normally, if there's no number in front of a variable, or if there's no exponent, we think of it as 1. But in this case, we need to make sure that if there's no index, it is 2. Okay. Outside of the radical, you'll also have coefficients, right? So coefficients also go outside. Okay. That's a word we should already know. Radicand is the number that's inside. Do you need to know that outside of this class? Not going to lie. No one needs to know that. It's the number inside the radical. But it's the radicand. So on the quiz, you do need to know that. The radicand is the number inside. Right? And the whole thing is called a radical expression. So there are a few ways to simplify radical expressions. Okay? This way that they have here, this is called prime factorization. What that means is we want to take the number and we want to break it down into all of the prime numbers. Numbers can only be divided by themselves in 1, that the number is divisible by. This takes time, a lot of time, and it's tedious, okay? Because you have to factor the number completely, and that means breaking it down. So do you know what 72 is divisible by? Well, hopefully, great. But if you don't, then you need to start with, say, 2, because that's the smallest number that it could be divisible by that's not 1. So it would be 2. And then that's 36 divided by 2. And then that's 18, 2, 9, 3, and 3. And the reason I switched to 9 or 3 is because it's not divisible by 2 anymore. All right. They broke it down even further. Cross off one pair at a time, write it outside the radical. They're using pink for outside. Okay. But let's make it easier on ourselves. We're going to simplify it using the square root method. But I'm going to teach you a fast way in Desmos to use the square root method. Okay? So we are going to be simplifying the square root of 48. And I'm going to show you how they get all of these answers. I hate the color coding they've chosen. I will be doing something different. All right? So we're going to do this in Desmos. Our radicand is 48. So the first thing you are going to do is go to the plus sign, click add item, and add a table. All right. I would just change this to X so that way we don't have to worry about the subscript. It gets tedious if you leave the subscript, so just delete the subscript completely, type X. In the first column, we're going to type our radicand, which in this case was 48, divided by X. Okay. Okay. So what we're looking here is we're trying to find perfect squares. But if you're not sure of which are your perfect squares, that's going to be hard to do, right? So I add a third column. SQRT. Same thing you typed into the first column or the second column, 48 over X. Okay. And now we can see that anything with a whole number in this purple column, in the third column, those are our answers to square root. So that is our perfect square. We have a whole number here. So that means 16 is a perfect square. That means we're going to look at this set here. And I'm going to show you what we're going to do with it. I mean, it's already in the pictures, but I'm going to show you how it works for me. Okay, so I took a screenshot. And I'm going to actually put it over this one. Let's be honest, I'm not doing the negative numbers. I'm not doing for this. I'm not doing the 0. Okay, so when you find a whole number here, the highest whole number in this column, okay, is the coefficient. It goes outside. This is our coefficient. I think I spelled it wrong, but that's okay because it doesn't matter. All right. Oh, no, I didn't, according to this thing here. So this is going to go outside. Okay. We'll pretend I spelled that right. Okay. And then this is our radicand. It goes inside. Heh. I put a T. That's weird. Okay. So it goes inside. So we have radicand. And our coefficient. Okay. So let's try an example. Okay. Now, I know in the Amplify and on the original, it said square root of 89. 89 doesn't work. The square root of 89 is the square root of 89. It was as perfect as it could get, or was it 84? So we changed it to 80. It was 84, sorry. 84 doesn't work, so we switched it to 80 so for the example, okay? So the first thing I'm going to do, go to Desmos. Desmos is our friend. He is our hero, or she, or whatever. I don't know. It's our hero. Desmos is a hero. It's a superhero. We go to plus. We go to table. My header of the first column is X. My second column is 80 divided by X. And my third is square root of 80 divided by X. At some point, if you want to, you can eventually start skipping that middle column. I would keep it, but you can. All right. 1, 2, 3, 4, 5. Now, when do I stop? As soon as I get a whole number in that third column, I can stop. All right. I don't have to keep going because that's tedious. I'm going to go up to 10 though, just so we have it. Well, 8. Okay. So which pairing am I going to use? What is the X value that I'm going to use of these columns? You can see here there's a list of X values. Which X is the one I want to use? What is going to be inside my radical? 5. Perfect. Awesome. And we want that one because, again, it's the one that gave us a whole number in column 3. Okay. So remember, this is our coefficient. And I put that in the wrong color. I need to keep my colors consistent. Sorry. Coefficient. And the first column is our radicand. Right? So as Riley told us, the number we're gonna use is the one with the 5. So where does the 5 go? Inside or outside? Is it the coefficient or the radicand? And let me just make outside. Sorry, not outside, that's inside. My bad. I keep doing that. Inside, outside. So where's the 5 gonna go? Inside or outside? No, my drama. Any ideas? 5 goes inside or outside? Yes, London, you're fine. Right, inside, because it's the radicand. So therefore, what number goes on the outside? 4. Perfect. Okay. All right, so let's do 32. What is my first step? What should I do first? I'm actually just curious to see what you guys say is the first step. Table, perfect. Now, last class period, someone did get actually really specific, hyper specific, and said the first thing you do is click the plus sign. We're doing 32 and square root of. Perfect. Then take off the subtitles, 32 over x, subtitles, subscripts. Then just 1, 2, 3. Now see, where should I have stopped? Where would you have stopped? I could stop at that too. I did not need to keep going. I'm actually not even going to screenshot anything lower than that too. Because once I have that whole number in that third column, I have all the information I need. All right, so we have our radicand. You can just type SQRT. So like I would have like it, I'm going to type it how it would look. SQRT 32 over X, like that. Would have been fine. Okay. What number is going to be our radicand? What's going to be our inside number? 2. 4 square root 2. Perfect. That's exactly how I would have written that, Riley. Perfect. Right. Now, wouldn't you say this is a lot faster than trying to break it down by hand? I promise you it is. It's a lot faster than doing it by hand. And it's because when we get to these kind of exponent or these things like this, you might wonder why we wouldn't want to just put 5.656, you know, that kind of stuff. Why wouldn't we want to just put 5.656, 7, or 8? Why wouldn't we want to round it? Well, some things need very exact calculations. And so we don't put 3.14, we just put pi. We put 4 square root of 2 instead of 5.657, whatever we wanted to round to. Okay. Now, don't freak out yet. What do we do with this one? Okay, we're going to break it up. first. Let's break it down. If it's multiple choice, this is way easier, I promise. We're going to start with square root of 72. You can, but we're going to actually do an easier way on this because it's good. Since we're simplifying on this one, we don't have multiple choice. If we had multiple choice, we could do that, but it's easier if we do this, actually. I know this looks weird. First thing we're going to do, we're going to break it up. First thing we're going to do is let's do this one in Desmos. We're going to do the square root of 72. Okay. I could have just changed those numbers to 72s. Oh well. Okay, and then SQRT 72 over X. All right, so we're going to use 2. This is the way we're going to break it down. All right. Paste. So I'm going to put this right here. All right, so this one breaks down. What's going to be my, we're going to have 6 square root of 2. All right. Now, for the variables, what are we going to do? Well, our index is 2, right? That's what we're saying is the index. So what we need to look is for how many pairs can we get out of here. So if I break the M, I have 5 M's, right? 1, 2, 3, 4, 5. How many pairs do I have? How many sets of 2? 2 of them. 1, 2. So the outside is M, and then how many of them squared? So 2 pairs. And then how many do I have left? Just the 1. Okay. So I'm going to do it at the N. How many pairs of N's do I have? Because this one is N. We have N, we have M. Oh, why isn't it M? Because I messed up. That's why. Thank you. Because I messed up. Thank you for catching that. Awesome. Okay, I have 1 set of N's that I can take out. I don't really need an exponent if it's 1, but I'm just going to put it there for illustration purposes. And then I have 1 left inside. Oops. All right, and then the last one on the P. Do I have any pairs of P's? No, I can't do anything with the P. So it stays there. Then all I have to do is take everything that's on all the blues, all the outside numbers. So we have 6 M squared N, then our radical, and then what we had left on the inside, 2 M N P. Okay. So I find breaking it down into smaller pieces works way better for this. Yeah, because the 6 was the outside number over here. Yes, this is the answer. So let's break this one down. This one's a little bit easier, actually. We have the square root of 144, the square root of r cubed, the square root of s, and the square root of t to the 4th. Quick question, easy question. What is the square root of 144? That's a perfect square, so what is the square root? And don't forget, don't let arithmetic, things like square roots, squares, add, subtract, multiply, divide. Don't let that hold you up. Okay, and it is 12. Perfect. All right. But there would be nothing inside the radical because it's just perfect square. So let's look at r. How many pairs of r's do you think I have in r to the third? 1. Okay. And how many would be left over? 1. Perfect. Can I do anything with square root of s? No. And then the t? How many pairs of square root of t or t's? 2. And do I have anything left? No. 0 left. All right. So again, just everything I have written in blue or everything in front of a radical. 12 r t squared radical. And all I have left on the inside is rs. Okay. Everyone understand why we broke it down the way we did? How we got the breakdowns? Everyone good? So everything that's already outside stays outside. Everything that's inside stays inside. So whatever was left and couldn't get out. One of my classes once defined it as like a prison break. All right. So if we look at, let's say 144, square root of 144. That's the same thing of saying the square root of 12 times 12. So this is a pair, right? They can hold hands, they can break out together. And there's no one left inside, so there's no more jail, okay? But if we go back to say, like what we had earlier, I'm gonna go back up here, square root of 72, that's the same as saying the square root of 6 times 6 times 2, because 6 times 6 is 36. Again, I have a pair. They can break out together. But the 2 didn't have a buddy to escape with, so he has to stay in jail. So that's one of the strategies. Yeah, as long as you know, first column, inside, third column, outside. And then keep practicing whatever you write inside stays inside. If there's 2, let them loose. That's good. I like that. If there's 2 of them, if there's 2, let them loose. If there's 2, let loose. That's beautiful. All right, but if you're given a multiple choice expression, why make it hard on yourself, right? Desmos, it's our hero. So all we have to do on this, if you type it into the calculator, okay, 7 square root of 45, it's going to give us the decimal answer. Then we just put in each of these answers. See if it'll pull them all this time. Last class, perfect. All right. Then you can put them into Desmos. Okay. So we have 12 square root of 3, 35 square root 3, 10 square root 5. That's why we got to make sure we type correctly, Miss Millberry. SQRT 5 and 21 square root 5. Okay. So if we're looking at these answer choices, which one matches? Okay. Which one matches? That's right, D. Those of you putting D in there, good job. Right? Which one matches? And that's the easy way to do it if it gives you multiple choice, right? So that's how you do that one. That one's pretty easy. Just which one matches. All right, good job. Okay, now what to do? How can we do this one in Desmos? Well, it's actually easier than it looks. Now, somebody did tell me we could just change all the variables to X, and it works, but it's hard to read, so let's not do that, okay? What you're going to do is go into Desmos, and we have M, N, and P. We are going to set M, N, and P to values that are not 0 or 1, and 2 is iffy. So it's usually good to start with 3, 4, and P equals 5. It doesn't matter that we're going to get ridiculously large numbers. No, because we're comparing. All right. So our original expression is 20 m squared n to the 5th p. Okay. So square root of 20 m squared n to the 5th p. Wait, is that right? Yes, okay. And then all I have to do is type in the other answers. So personally, what I would do is knowing what I know. If I can break down the square root of 20, I would know that I want to look for these two that are 2 and 5. Okay, because it's 4 times 5, and the square root of 4 is 2, and it comes out. But if you break it down by hand, you can actually do it, to check these two at the bottom first. Now, my question is, do you think the P would come out on this one? Let's look at the answer choices. Is the P going to be inside or outside? Inside. So I'm going to activate the poll. And I want you, instead of telling me what the answer you think it is, which answer do you think I should check first? Which answer do you think I should check first? And I'm going to give you guys about 15 seconds to decide which one you think I should do to demonstrate first. So I'm going to go ahead and set that timer. Right now, it looks like C is winning. We got a combination between C and B. Okay, perfect. So of the 8 people who answered, 4 of you were saying I should check C first. So that's the first one I'm going to check. My question is, once you know which one you should check first, do you really think that if you get it right the first time, you should keep checking them? 2mn squared. Okay, so since this is the first one, does this one match? Yeah, so if it matches, I can actually stop there. I don't have to keep searching for an answer once I have an answer, all right? Especially on Star, I mean, you guys, it's not like you're in brick and mortar. You guys only have to be there in the room for at least an hour. After that, once you're finished, you're done, you can go, all right? So don't even panic. Oh, wow. Oh, we did the, there's a Wayground you can practice with later if you want to. We don't really have time to do it in class today, but the QR code will be on the notes once I post them to Google, to Canvas. And it's a clickable link. I'm not going to flatten my annotation, so you can click on the links. All right, let's do the exit ticket because class ends in 10 minutes. Is there anything you need to complete today? Nothing is due today. The quiz is due Thursday. I recommend not doing the quizzes until we do the reviews. And there's a reason for that, and I'll explain in just a moment. While you guys are thinking about the answer to this, I want you guys to go ahead and answer this question. I'm going to let you know that starting on Wednesday, again, it's not starting today because I have a meeting at 3 at my daughter's school, so I have to leave at 2:30. Starting Wednesday at 2:30, Wednesday, Friday, and then Monday, Wednesday, Friday, whenever we're in school and I'm not sick. We will be having regular tutoring times. Generally speaking, what we do during the tutoring times is play Blooket or Gimkit. All right, so if there is anything you needed specific help with, you can always come ask me for specific help at those times. We can go to a table and I can tutor you there. But if you don't have anything you want specific help with, you just want to come and hang with members of your class and get some math practice in, and yeah, that's also good. And we always have a lot of fun. I am opening it up to where you can bring your friends from other classes because, you know, a lot of my students liked to go to those. So I did open it up to, I put guest links in as well. All right, so most of you are saying C, or sorry, B. Awesome. I put in a guest link to the Engagely. So if you give them the guest link, you can they can come. But they might be able to do it with the regular link since you are students. They have to be students. All right. So 500 is the same as 5 times 100. 100 is a perfect square. So we can say that the square root of 500 is equal to the square root of 100 times the square root of 5. Square root of 100 is 10. Square root of 5 stays the same. So if you said B, congratulations, that is the correct answer.